Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter functions. So any doubts if you have in any steps, then please write that in the comment section. We shall obviously clarify them in the subsequent videos. And also in any other chapter of maths, if you have more difficulty, then please mention the name of that chapter also in the comment section. So that we can give more priority on it and solve more questions on that chapter. So here it is told that let alpha, beta and gamma be three positive real numbers where f of x equals to alpha x power 5 plus beta x power 3 plus gamma x such that g of f of x that is equal to x for all x belongs to R if a1, a2, a3 till an be in arithmetic progression with mean 0, then the value of f of g of this is how much. So f of g of 1 by n summation I goes from 1 to n f of ai, that we have to find out. This you have to find. So this I can write, this will be f of 1 by n summation g of f of ai, I goes from 1 to n. Now g of f of x is x, so this will be ai only. So this will be f of 1 by n summation ai, where I goes from 1 to n. So it means this will be actually 1 by n times summation f of ai, I goes from 1 to n. So this value we have to find out. Now f of ai, that we can say that will be equal to alpha ai power 5 plus beta into ai power 3 plus gamma into ai. Now therefore summation f of ai, I goes from 1 to n, that will be equal to alpha into summation ai power 5, I goes from 1 to n, plus beta into summation ai cube, I goes from 1 to n, plus this will be gamma into summation ai, I goes from 1 to n. So it is told that their arithmetic mean is 0 only. So it means that we have same number of negative terms as the number of positive terms. So it means the sum of the positive terms should be equal to the sum of the negative terms. So this will be equal to 0 only. So alpha into 0 plus beta into 0 plus gamma into 0. So that will be 0. So option A is the correct answer. Then here it is told let f of f comma g maps from n minus 1 to n be functions defined by f of a equals to a. No, f of a equals to alpha, where alpha is the maximum of the powers of those primes p such that p power alpha divides a. P power alpha divides a, and g of a that is equal to a plus 1 for all a belongs to n minus 1. Then the function f plus g is. So all natural numbers except 1 we should take. Suppose for example if we find f of 2, so maximum of the powers of those primes that is divides a. Okay, so it means that 2 power 1 divides a, 2 power 1 divides 2. So therefore here alpha is 1. So f of 2 is 1. Similarly f of 3 that will be also equal to 1. Since y 3 power 1 divides 3. So therefore f of 2 is also 1, f of 3 is also 1. So therefore it is not 1 1. It is not 1 1. And g of 2, so f is not 1 1, but g of 2, that will be equal to 2 plus 1, that is 3, and g of 3, that will be equal to 4. So therefore f plus g of 2, that will be equal to 1 plus 3, that is 4. And f plus g of 3, that will be equal to f of 3 plus g of 3. So that is 5. So it means it will be 1 1. So f plus g is 1 1. Since why g plus f plus g is 1 1. And so here we can say that here also in g we cannot put 1. So therefore um, f plus g, for f plus g, the minimum value will be f plus g of 2, that is 1 plus 3, that is 4. So this is the minimum value of f plus g. Now here it has been told that f plus g also will map from n minus 1 to n. But here if you take n minus 1 to n minus 1, 2, and 3, so except 1, 2, and 3, all natural numbers we can get. So then it will be onto. So it means that f plus g is 1, 1 also and onto also. So it is both 1, 1 and onto. So option C is the correct answer. Then here it is told the number of bijective functions f, which is, so bijective, it means it is 1, 1, it should be 1, 1 and onto. Should be 1, 1 and onto. Now the function f that maps from 1, 3, 5. So all odd numbers from 1 to 99 to all the even numbers from 2 to 100. So it means all the odd numbers from 1 to 100, it maps to all the even numbers from 1 to 100. Such that f of 3 is greater than or equal to f of 9 is greater than or equal to f of 15 is greater than or equal to till f of 99. So here actually we are adding 6. So how many numbers will be there? So these are in AP only. So it means that we have restrictions for how many elements. So there is restriction for 3, 9, 15, etc. till 99. So how many numbers are there here? So this is an AP. So 99 is the nth term. So the number of terms will be 99 minus 3. 99 minus 3 by 6 plus 1. So this will be 96 by 6. 6 1 is 6. 6 is 36, 16, 6 is 96 plus 1, that is 17 terms. So there are 17 terms. So here, so it means out of these, so here actually we have got 50 numbers. 50 terms are matching with 50 numbers here. So therefore, uh, so for these 17 elements, there are some restrictions. So except these 17, there are 33 elements. So it means that these 50 elements will map with the remaining 33 elements will map with any 33 elements here. So 50C33, we will select 33. And then we can arrange them also. In 33 factorial ways. So this will be 50 factorial by 33 factorial into 17 factorial into 33 factorial. So this is nothing but 50 factorial by 50 minus 33 factorial. So this is nothing but 50p33. So option B is the correct answer. So these many bijective functions we will have. Then here it is told the total number of functions which map from the set 1, 2, 3, 4 to 1, 2, 3, 4, 5, 6. Such that f of 1 plus f of 2 that is equal to f of 3. So suppose if you take f of 1 as 1 and f of 2 as 2, then f of 3 will be 3. So it means that 1 plus 2 that can be 3, or 1 plus 3 that can be 4, which is there in the 1 plus, yeah. Here 1 plus 2 that can be 3, which is there in the range of the function f, or I can say this is the codomain, the function f. So f of 1 also should be there in the codomain, and f of 2 also should be there in the codomain. 1 plus 2 can be 3, 1 plus 3 can be 4. Then we can take 1 plus 4 that can be 5. Then 1 plus 5 we can take that can be 6. Or here we can have like 2 plus 3 that can be 5. 2 plus 4 that can be 6. Plus 4. 2 plus 5 we cannot take. Then 3 plus 2. Yeah, so 3 plus 2 also we can do. And 3 plus 1 also we can do. Okay, 3 plus 4 we cannot do. So it means here we have here we can have 4 plus 2, 6, 6 into 2. In 6 into 2 ways we can choose f of 1 and f of 2 and f of 3. F of 1, f of 2 and f of 3. F of 3 will be automatically chosen. F of 1, f of 2 and f of 3. And here we can either okay, any 3 elements we have been chosen. So for the fourth element which is 4, f of 4, that can map with any other 3 elements. So that will be in 3C1 ways. Or we can map that with these 3 also. So for the fourth one, we have 6 options. For the fourth element, we have 6 options. So that will be 36, 36 into 2, there will be 72 functions. Then Okay, so it will be f of 1 plus f of 2, that is equal to f of 3. 1 plus 2, that will be 3. 1 plus 3, that is 4. 1 plus 4, that is 5. 1 plus 5, that can be 6. Or we can also do like this, 1 plus 1. F of 1 also can be 1. F of 2 also can be 1. Both map with 1. So 1 plus 1, that will be 2. That also we can do. And 2 plus 2 also we can do. That will be 4. Then 3 plus 3 also we can do. That will be 6. 4 plus 4 we can't do. Okay. So these are the 3 ways also we can choose. So there will be 6 2s are 12. 12 ways. 12 plus 3, that is 15. 15 ways. 15 into 6, that will be 90 functions. That will be 90 functions. Since way in this way also we can choose f of 1 and f of 2 and f of 3. So there will be 90 functions. So option B is the correct answer. Then here it is told, let a function f maps n to n be defined by f of n, that is equal to 2n for where n is even number, or we can tell it is of the form 4n plus 2 form, 4m plus 2 form, or 4m minus 2 form, where m is the natural number. And that will be n minus 1, where n is of the form 4m minus 1, where m belongs to n. And that will be n plus 1 by 2 when n is of the form 4m minus 3. M belongs to n. So it means that f of n, that will be equal to actually 4m minus 2, that is 2n. 2n, so that is 8m minus 4. That will come 4m minus 1 minus 1. So this will be 4m minus 2. And this will be 4m minus 3. So 4m minus 2 by 2. That will be 2m minus 1. Where m belongs to n. M belongs to n. So where n is of the form 4m minus 2. Here n is of the form 4m minus 1. And here n is of the form 4m minus 3. So here, as you can see, we will get all these will be multiples of 4 only, since we can write it 4 into 2m minus 1. So this will be odd multiples of 4. These will be all odd numbers. These will be all even numbers except which are multiples of 4. So it means that it is obviously a 1 1 function, and obviously it will be an onto function also. So it is 1 1 and onto. So option D is the correct answer. Let f maps from R to R be defined as f of x equal to x minus 1, and g maps from R minus 1 comma minus 1 to R, which is defined as g of x equal to x square by x square minus 1. Then the function f of g is So f of x, so that is f of g of x, so that will be g of x minus 1. So this will be x square by x square minus 1 minus 1. This will be x square minus x square plus 1 by x square minus 1. So this will be 1 by x square minus 1. So now 1 by x square minus 1 is this 1, 1 and 1, 2 that we have to find out. Now f of g of x, so that will map from R to R. F of g. F of g will map from the domain of g to the range of R. So it means it will map from R minus 1 comma minus 1 to R. So this will be the domain of f of g. This will be the range of f of g. So now is this 1, 1 or 1, 2 that we have to find out. So if we find d by dx of this 1 by x square minus 1, that will give us minus 1 by x square minus 1 whole square into 2x. So this is minus 2x by x square minus 1 whole square. So when x is greater than 0, this function is decreasing, and when x is less than 0, it is increasing. And x tends to plus minus infinity, that is 0 only. So the graph of this function, x less than 0, it is increasing. X tends to minus 1, that will be 0 also. So this is x equal to 0. This is x equal to 0. No, y equal to 0. And this is y equal to 1. At x equal to 0, it will be minus 1. Equal to 0, it is minus 1. And for x less than 0, it is increasing. So it is decreasing for x greater than 0, and it is increasing for x less than 0. So it means that it should not be 1, 1. It is not 1, 1. Since y, for example, f of minus 2 also is f of g of x. So now it means f of g of minus 2 also will be equal to f of g of 2. So it is not 1, 1. And it is not on 2 also, since y x square will be greater than or equal to 0 always, and x square minus 1 will be greater than or equal to minus 1 always. So 1 by x square minus 1, that will be and it will go till infinity. So it will go from, it will be less than 0. So minus 1, that will be less than, can be positive also. But it will go from minus 1 to 0 only. So x square minus 1 will be greater than or equal to minus 1 always. It can be 0 also. So it will go till infinity. So it can go from minus 1 to infinity. So the whole real number set won't be the range. So it is neither 1 1 nor on 2. So option D is the correct answer. Then here it is told if f of x that is equal to x minus 1 by x plus 1 and x belongs to r minus 0 minus 1 1, and if f of n plus 1 of x that is equal to f of n of x for all n belongs to n, then f6 power 6 plus f7 of 7, f6 of 6 plus f7 of 7, that is equal to how much? Okay, so now f of x, that will be how much? That will be equal to f of x minus 1 by f of x plus 1. So that will be x minus 1 by x plus 1 minus 1 by x minus 1 by x plus 1 plus 1. So this will be x minus 1 minus x minus 1 divided by x minus 1 plus x plus 1. So 1 will cancel. This here also x will cancel. So this will be minus 2 by 2x. So this will be minus 1 by x. And this is equal to f2 of x actually. f2 of x. So therefore f2 of x that is equal to minus 1 by x. Similarly f3 of x that will be f of f2 of x. So that will be f2 of x minus 1 by f2 of x plus 1. So that will be minus 1 by x minus 1 by minus 1 by x plus 1. So that will be minus 1 minus x divided by minus 1 plus x. So this will be minus of x plus 1 by x minus 1. Okay. And then f4 of x. That will be f3 of x, which is x plus 1 by 1 minus x minus 1 by x plus 1 by 1 minus x plus 1. So this will be x plus 1 minus 1 plus x divided by x plus 1 plus 1 minus x. So that will be 1 will cancel. So this is 2x by 2 that is equal to x. So f4 of x that is equal to x. So therefore f5 of x that is nothing but x minus 1 by x plus 1, which is same as f of x. Now f6 of x. So f6 of x that will be equal to f2 of x, which is minus 1 by x. And f7 of x that will be equal to f3 of x, that is equal to x plus 1 by 1 minus x. So now therefore we have to find f6 of, so this is okay, f6 of 6 plus f7 of 7, that we have to find out. So f6 of 6 that will be equal to minus 1 by 6 plus this will be f7 of 7, that is 7 plus 1 by 1 minus 7. So that is minus 1 by 6 plus this is 8 by minus 6. So this is minus 9 by 6. So that is 3 to the 6, 3 to the 9. So that is minus 3 by 2. Minus 3 by 2. So option B is the correct answer. Then here it is told, let f maps from n to r be a function such that f of x plus y that is equal to 2 into f of x into f of y. For natural numbers x and y, if f of 1 is equal to 2, f of 1 is 2, then the value of alpha we have to find such that summation k goes from 1 to n, 1 to 10, f of alpha plus k, that is equal to 512 by 3 into 2 power 20 minus 1. Okay, so now f of two, if you want to find f of 2, that will be equal to f of 1 plus 1. So that will be equal to 2 into f of 1 whole square. So that will be 2 into 2 square. So that is 2 power 3. Similarly, f of 3, that will be equal to f of 1 plus 2. That is equal to 2 into f of 1 into f of 2. So this will be 2 into f of 1, that is 2, into f of 2, that is 2 power 3. So that is 2 power 5. Similarly, f of 4, that will be 2 into 2 into 2 power 5. So that is 2 power 7. Okay, so therefore now f of alpha plus k, that can be written as 2 into f of alpha plus into f of k. Now therefore here you can see that this is so it is 3, this is 5, 2 3 is 6 minus 1, 2 to the 4 minus 1. Two ones are 2 minus 1. Okay, so this is 2 power 1. Okay, so therefore you can say f of k, that will be equal to 2 power 2k minus 1. Therefore f of alpha plus k, therefore f of alpha plus k, that can be written as 2 power 2 into alpha plus k minus 1. So therefore summation k goes from 1 to 10, f of alpha plus k, that will be equal, that is given as 2, this 512 I can write 2 power 9 by 3 to 2 power 10 whole square minus 1, and this 3 I can write it as 2 power 2 minus 1 also, and this one I can write 2 power 9 into 2 power 2 whole power 10 minus 1 divided by 2 square minus 1. So it means that it is acting like a GP. So this will be summation k goes from 1 to 10, 2 power 2 into alpha plus k minus 1. So that is given as 2 power 9 into 2 power 2 whole square minus 1 by 2 power 2 minus 1. Therefore the first term will be for k equal to 1, that is 2 power 2 into alpha plus 1 minus 1, plus this will be 2 power 2 into alpha plus 2 minus 1. Okay, plus it will go till 2 power 2 into alpha plus 10 minus 1. So therefore now here you can see that the common ratio, this one is 2 power 2 alpha plus 2 minus 1, so plus 1. This is 2 power 2 alpha plus 4 minus 1, so plus 3. This is 2 power 2 alpha plus 20 minus 1, that is 19. Okay, so it means here we have, obviously we have 10 terms. 10 terms is 19 minus 1 by 2 plus 1, that is by 2. Yeah, 10 terms are there. So this is, it was power 10. So here the first term that is first term of, so here you can see one geometric progression GP has been formed. So the first term of the GP is 2 power 2 alpha plus 1, and the common ratio R, common ratio is 2 power 2. So therefore the first term is 2 power 9. So the sum of these 10 terms, there are 10 terms, sum of 10 terms will be a into r power 10 minus 1 by r minus 1. So it means r is 2 power 2. And the first term is 2 power 2 alpha plus 1, which is same as 2 power 9. So therefore 2 alpha plus 1 that is equal to 9. So 2 alpha that is equal to 8. So alpha equal to 4. So alpha should be equal to 4. So option C is the correct answer. Then here it is told if the function f maps from R to R and g maps from R to R, be two functions defined by f of x equals to log base e x square plus 1 minus e power minus x plus 1 and g of x that is equal to 1 plus 1 minus 2 e power 2x by e power x, then which of the following range of for which of the following range of alpha the inequality f of g of alpha minus 1 whole square by 3 that is greater than f of g of alpha minus 5 by 3 holds. Okay. So here it is told f of x is this. So now here if we do f dash x, then we will get 1 by x square plus 1 into 2x minus, so plus e power minus x. So here for yeah, so this value will be always greater than 0 only. This will be greater than 0 since y f, so there for all x belongs to R. So therefore we can say that the function f of x is an increasing function. It is increasing. And g of x, so if you find g dash x, that will be equal to, so this you can write e power minus x minus 2 e power x. So d by dx of this, so that will be minus e power minus x minus 2 e power x. So this will be obviously less than 0 for all x belongs to R. So therefore, so I can say g of x is a decreasing function. G of x is a decreasing function and f of x is an increasing function. So now g of x is decreasing. It means that g, if suppose a is greater than b, then g of a that will be less than g of b. Since why? Since g is decreasing. So with increasing value, the function's value will decrease. And if suppose if I tell c is greater than d, then f of c will be obviously greater than f of d, since why f is a increasing function. So now since g of a is less than g of b, so I can say that f of g of a also will be less than f of g of b. F of g of b. So it means that here it is told that so it means that if we tell that f of g of b that is greater than f of g of a, that means that implies that b should be less than a. So therefore here also it is told f of g of this is more than this. So it means this value should be less than this value. So it means alpha minus 1 whole square by 3 that should be less than alpha minus 5 by 3. Then you have to find the range of alpha. So then we can take 3 as LCM and we can cancel. So this will be alpha minus 1 whole square is less than 3 alpha minus 5. 3 we can cancel out. Then we can say alpha square plus 1 minus 2 alpha, that is less than 3 alpha minus 5. So therefore I can say alpha square minus 5 alpha plus 6, that is less than 0. So it means if we factorize it, then we'll get alpha minus 2 into alpha minus 3, that is less than 0. So it means alpha should belong to the set 2 to 3. So it should be from 2 to 3. So the range of alpha is 2 to 3. So option A is the correct answer. Then here it is told for P comma Q belongs to R, consider the real valued function f of x equals to x minus p whole square minus q, where x belongs to R and q greater than 0. Let a1, a2, a3 and a4 be in arithmetic progression with mean p. So mean value is p and positive common difference. So mean value is p. So therefore, let's say we can take a1 as p minus 3d, where d is the suppose is the positive common difference, positive common difference of the AP, positive common difference of the arithmetic progression. So it means d is greater than 0. So a1 is p minus 3d. So therefore a2 will be p. So no, here the common difference is suppose 2d, where d is greater than 0. So 2d is the positive common difference. Then we can say a1 is p minus 3d, then a2 should be p minus d, and a3 should be p plus d, and a4 should be p plus 3d. Since why, if we take their mean will come, so if we add them, then these will, the d will get cancelled and it will be 4p by 4, so that will be p. So the mean of them is p only. So now it is told if mod of f of ai that is equal to 500 for all I equal to 1, 2, 3, 4, then the absolute difference in between the roots of f of x equal to 0 is absolute difference between the roots. So now roots of this we have to find. So if we take this equal to 0, then we will get x minus p whole square, that is equal to q. So it means that x minus p, that will be equal to plus or minus q, plus or minus root q, then x will be equal to p plus or minus root q. So therefore the absolute difference, the difference between the roots, absolute value of the difference between the roots, that will be p plus root q minus of p minus root q. So that will be equal to 2 root q. pp will cancel out. So 2 root q, that value has been asked. We have to find out. Now it is told mod of f of ai that is equal to 500. Mod of f of ai that is equal to 500. So suppose if we take this a3, so therefore mod of f of a3 that will be equal to 500. So therefore we can say mod of a3 minus p whole square minus q, that is equal to 500. So therefore we can say p a3 minus p, that will be p a3 minus p, that will be equal to d. So d square minus q mod, that is equal to 500. And also if we take mod of f of a5, no a4, that will be also equal to 500. So therefore we can say that f of a4 that will be equal to 3d whole square minus q. So that will be 9d square minus q. So this will be mod of 9d square minus q, that is equal to 500. So therefore we can say 9d square minus q mod, that is equal to mod of d square minus q. So there can be two cases. Case 1, it can be that 9d square minus q, that can be equal to d square minus q. Then we will have this will cancel, then we will get 8d square equal to 0. So d will be equal to 0. So it means case 1 we can't take, since it is told that the difference, the common difference of the AP should be positive. should be having a positive common difference. So we can't take the case 1. So now case 2 we can take. So that will be 9d square minus q, that is equal to minus d square plus q. So it means that then we will get 10d square, that is equal to 2q. 10d square, that is equal to 2q. 10d square, that is equal to 2q. So therefore q, that is equal to 5d square. Q, that is equal to 5d square, or I can say d square, that is equal to q by 5. So therefore we can say that mod of q by 5 minus q, that is equal to 500. So therefore we can say this will be q minus q by 5, that is equal to 500. So therefore I can say this will be 4q by 5, that is equal to 500. So therefore q will be equal to 2500, 5 5 is 25 by 4. So therefore root q, that will be equal to 50 by 2. So therefore 2 root q, that will be equal to 50. So 50 is the absolute value of the difference in between the roots. So 50 is the answer. Yeah, so here it is told that the number of functions f from the set A, which is x belongs to n, such that x square minus 10x plus 9, that is less than or equal to 0. So if we factorize it, then we'll get x minus 1 into x minus 9, that is less than or equal to 0. So it means that x should, so therefore the set A, that should be from 1 to 9. We should take all the natural numbers from 1 to 9. 1, 2, 3 till 9. And the set B is the set of n square. So the square of all the natural numbers, that is 1, 4, 9, 16, etc. And it is told such that, so f is a set which, so f is a function which maps from the set A to B. A contains 1, 2, 3 till 9, and it contains 1, 4, 9, etc. So this function f maps from A to B such that f of x, that is less than or equal to x minus 3 whole square plus 1. Okay, so f of x, so if I take x equal to suppose 1, then 1 minus 3 whole square plus 1, that is equal to 2 square, so that is 5. So it means that f of 1, that should be less than or equal to 5. So therefore f of 1, it has got two options, 1 or 4. Similarly, for x equal to 2, it will be 2 minus 3 whole square plus 1. So that will be equal to 1 square, 1 plus 1, that is 2. So therefore f of 2 should be less than or equal to 2. So it has only one option, that is 1. And for x equal to 3, we have 3 minus 3 whole square plus 1, that is equal to 1. So it means that f of 3 has only one option. So f of 3 should be less than or equal to 1. So it has only one option, that is 1. Similarly, for x equal to 4, you can say 4 minus 3 whole square plus 1, that is equal to 1. minus 3 whole square plus 1, that is equal to 1 plus 1, that is 2. So f of 4, that should be less than or equal to 2, so it has only one option. And then for x equal to 5, for x equal to 5, it will be 5 minus 3 whole square plus 1, that is 2 squares, that is 5. So f of 5 has, that should be less than or equal to 5, so it has two options, 1 and 4. And then for x equal to 6, it will have 6 minus 3 whole square plus 1. So that will be equal to 3 square, 9 plus 1, 10. So f of 6 should be less than or equal to 10. So it has three options, 1, 4, and 9. So for x equal to 7, since x can go from 1 to 9. So for x equal to 7, it will be 7 minus 3 whole square plus 1, that is 4 square, 16 plus 1, that is 17. So f of 7, that should be less than or equal to 17. So it has four options, 1, 4, 9, and 16. Then therefore for x equal to 8, we'll have 8 minus 3 whole square plus 1. So that will be equal to 5 square plus 1, that is 25 plus 1, that is equal to 26. Plus 1, that is equal to 26. So for x equal to 8, it will be 8 minus 3 whole square plus 1, that is 25 to 26. So f of 8, that should be less than or equal to 26. So it should be 1, 4, 9, 16, and 25. So it has 5 options. Then for x equal to 9, 9 minus 3 whole square plus 1, that is 6 square, 36 plus 1, that is 37. So f of 9, that should be less than or equal to 37. So it will have 1, 4, 9, 16, 25, and 36. So it will have 6 options. So therefore, the total number of functions f that can be formed, the total number of functions that can be formed from the set A to B under the following, under this condition. So that will be equal to, this is the, so here we have 6 options. So 6 into, here we have 5 options. Here we have 4 options. Here we have 3 options. Here we have 2 options. And here we have 1 option, and here again 1 and 2 option. So 1 and 2 option. Here 3, here 2, here 1, 1, 1 and 2. Okay, so this will come 6 is a 30, 4 6 are 24, 24 into 2, 48. So this will be 6 4 are 24, 24 into 2, that is 48. So 3 8s are 24, so the 12, 1 4 4 0. So there are 1440 functions from the set A to B. And here it is told, let f of x, that is equal to 2x square minus x minus 1, and s be all n belongs to z such that f of n, mod of f of n, that is less than or equal to 800. So therefore mod of 2x square, so f of n, that is mod of 2n square minus n minus 1, that should be less than or equal to 800. So therefore it means 2n square minus n minus 1, that should be less than or equal to 800 and more than or equal to minus 800. So therefore we can take case 1, that is 2n square minus n minus 1, that is greater than or equal to minus 800, and also 2n square minus 8 minus 1, that is less than or equal to 800. So if we solve it, then we will get 2n square minus n plus 800 minus 1, so that is plus 799, that is greater than or equal to 0. And this will be 2n square minus n minus 801, that is less than or equal to 0. So here if we solve it, then we will get this is so if we solve this quadratic equation, then we will get n equal to minus b plus or minus square root of b square b square minus 4ac. So here discriminant is negative. Your discriminant is coming negative. So this value will be always greater than 0 only, since we can write it in the form of a perfect square. That is, we can write 2 into n square minus n by 2. So 2 into n into 1 by 4. So we need plus 1 by 16. 8 is 16. By 8. So plus this will be 799 minus 1 by 8. That should be greater than or equal to 0. So this will be always positive only, since why this we can write 2 into n minus 1 by 4 whole square plus 799 minus 1 by 8, that is greater than or equal to 0. So it is always true. But here n will be equal to minus b plus or minus square root of b square minus 4ac. So plus 8 into 801 4ac b square minus 4ac by 2a, that is 4. So n will be equal to 1 plus minus square root of 8 ones 8, 8 is 64, 6409 divided by 4. So therefore n will belong to 1 minus root over 6409 divided by 4 till 1 plus root over 6409 divided by 4. These two values are included, and here we have to take the integers only. Integers. So root over 6409, it is approximately 80 point something. 80 point something. This is 1 minus 80 by 4. So this is minus 79 by 4. So this is minus 4 ones of 4. 4 nines are 36. 19.75. So this is, so therefore n will belong to minus 20 to this will be 80 approximately. So this will be 81 by 4, that is 20 point something. 4 to the 8, 20.25. So the integral part only we have to take, since n should be in integers only. So this will be 20. So it will go from minus 20 to 20 only. So therefore n will belong to this minus 20, minus 19, minus 18 till 20. So only the integers we have to take. Now we need to find value of summation f of n belongs to S, where S is the solution set. So therefore, actually, this is only the solution set S. So it means we have to do summation n belongs to S, f of n that will be 2n square minus n minus 1. So this will be 2 into summation n square, and it will go from n equal to minus 20 to minus 22 plus 20, and minus this is summation n goes from minus 22 plus 20 n minus this is summation 1 goes from n equal to minus 22 plus 20. So this will be equal to 2 into n square. So this will be 2 into also 2 into 1 square plus 2 square plus 3 square plus till 20 square. Then minus this will be the sum of all these elements, that will be 0 only. Then minus this will come 41 times. So minus 41. So this will be 4 into this n into n plus 1 by n into n plus 1 into 2n plus 1. 2n plus 1, 2 rows of 40, 41 by 6. And n into n plus 1 into 2n plus 1 by 6 minus 41. So this will be 2 to the 4, 2 3 is 6, 3 7s are 21. So this will be 21 into 20 into 41 minus 41. Forty-one into, so will be 20 into 21, that is 2 ones, 2 to so 4, 420 minus 1. 41 into 400 minus 1, so it is 41 into 419. So 41 into 419, that we have to do. So that is 914, and 4 nines are 36. 1s are 476. 4 4s are 16. So this will be 977. Oh, so yeah, so it will be 17179. So it is 17,179. This is the answer of summation f of n, where n belongs to S. Then here it is told, let f of x be a quadratic polynomial with leading coefficient 1. So therefore, let say f of x is equal to x square plus ax plus b. The leading coefficient is 1 and f of 0 that is equal to p. So therefore, the equation will be f of x equals to x square plus ax plus p. Since y f of 0 is b, so b equal to p. F of ax plus p, and if p is not equal to 0 also, and f of 1 equal to 1 by 3. So f of 1 that is equal to 1 plus a plus p, that is equal to 1 by 3. So therefore a will be equal to 1 by 3 minus 1 minus p. So this will be equal to minus p minus 2 by 3. This is equal to a. If the equation f of x equal to 0 and f of x equal to 0 have a common real root, then f of minus 3 is equal to. So therefore the function f of x that is equal to x square minus of p plus 2 by 3 into x plus p. So these two equations have a common root. F of 0 is p. F of x equal to 0, and so now f of x, that will be x square f of x whole square, that is x square plus ax plus p whole square plus a into x square plus ax plus p plus p. It is saying that it has a common real root. Of 1 is 1 by 3. Now this we can write x square minus px, x square minus px plus p minus 2 by 3x. Now therefore the root that will be x equal to minus b p plus 2 by 3 plus minus b square p square minus 4ac p square minus 4ac by 2a. So this will be p plus 2 by 3 plus or minus square root of p square plus 4 by 9 plus 4p by 3 minus 4p divided by 2 plus 2ab. So this will be p plus 2 by 3 plus or minus square root of p square minus 3/4 are 12 minus 8p by 3 plus 4 by 9, okay, by 2. So now here one thing we can do, let's say here, let's suppose alpha is the common root, so then f of alpha will be 0. So then here also f of f of f of f of f of alpha, that will be equal to 0. So f of alpha is 0 only, so therefore I can write f of alpha that is 0, f of 0 that is equal to 0. Now f of 0 that is equal to p, so this will be p, so f of p that is equal to 0 again. Now it means that f of p that is 0, of p that is equal to 0. So it means that now f of alpha that is 0, so alpha is nothing but f of p. Now therefore f of p that will be equal to e square plus ap plus p Now therefore f of p that will be equal to p square plus ap plus p whole square, yeah, of p is alpha. Now alpha into alpha is a root. Yeah, so here um, so it is a quadratic polynomial. So let's take it, let's say its roots are alpha and beta. Suppose alpha and beta are its roots. So then the function f of x, we can write the function f of x as x minus alpha into x minus uh, b- beta, x minus alpha into x minus beta is the quadratic polynomial. Then it is told that f of 0, that is p, is equal to p. So it means if we put x equal to 0 here, then alpha into beta we will get, that will be equal to p. So alpha beta is p, and f of 1, that will be equal to 1 minus alpha into 1 minus beta, that is equal to 1 by 3. And we have to find f of minus 3. So here it is told that the equation, so f of x equal to 0 and f of x is equal to 0 have a common real root. So let the common real root be alpha. Let the common root be alpha. Then therefore I can say that f of alpha, that is equal to 0. So therefore I can say f of x, that is 0. So let's say alpha is the common root, so I can say of alpha, that will be 0. So now f of alpha is 0 also. So I can say this will be uh, f of alpha is 0. So f of 0, that is also 0. Now f of 0, that is equal to p, that has been told. So this is p. So f of p, that is equal to 0. So now it means now p is alpha beta. So therefore it means that here we can say that f of p is f of alpha beta, that is equal to 0. So it means that now f of alpha beta, that will be equal to alpha beta minus alpha into alpha beta minus beta. So this will be alpha into beta minus 1 into from here beta I can take as common into alpha minus 1, that is equal to this f of alpha beta. So therefore f of alpha beta, that is equal to, this is alpha beta, that is equal to p into this 1 minus alpha into this, also you can write alpha minus 1 into beta minus 1, that also will be equal to 1 by 3. So this will be equal to p into 1 by 3, that is p by 3. So therefore now f of p by 3, that is equal to 0. Which is p by 3. It means what? F of alpha beta by 3, that is equal to 0. So therefore I can say this will be yeah. is equal to 1 by 3. Alpha beta by 3, if we tell that is equal to alpha, then we can tell beta will be equal to 3. So if beta equal to 3, then therefore I can say alpha minus 1 into 3 minus 1, that is equal to 1 by 3. So therefore alpha minus 1, that is equal to, this is 1 by 6. So therefore alpha will be equal to 7 by 6. So therefore now the f of x, that is equal to x minus 7 by 6 and into x minus 3. Since alpha is 7 by 6 and beta is 3. So therefore f of minus 3 we have to find out. So that will be minus 3 minus 7 by 6 minus 3 minus 3. So that will be equal to 3 6 18, 18 plus 7, that is 25 by 6 into 9. No, sorry, 3 to the 6. So this is equal to 25. So it means 25 is the answer. Then here it is told let f of x and g of x be two real polynomials of degree 2 and 1 respectively. Then so it means that f of x, it is a polynomial of degree 2. So I can say it is of the form ax square plus bx plus c, and g of x is a polynomial of degree 1. So it is of the form like suppose dx plus f, dx plus f. Now therefore here we can say that, so therefore now f of g of x, that will be equal to a into gx g of x whole square plus b into g of x plus c, and g of f of x, that will be equal to d into f of x plus f. So this will be equal to d into ax square plus bx plus c plus f. So this will be equal to adx square plus bdx plus cd plus f. Here also this will be a into dx plus f whole square plus b into dx plus f plus c. So this will be equal to a dx square, a d square x square plus this will be 2 df, yeah, 2 adfx, and plus this is bd plus bdx plus this is af square plus bf plus c. So therefore from, if we compare this, then we'll get one is ad equal to 4, bd equal to 6, and cd plus f equal to 1. And from here you can say that ad square equal to 8 and 2adf plus bd, that is equal to 0. No, that is equal to minus 2. And af square plus bf plus c, that is equal to 0. So ad square is 8. So therefore d will be equal to 8 by ad. Ad is 4. So d is equal to 2. So d is equal to 2 means b equal to 3. And then from here bd we know, ad also. Okay, so from here f we can find. So it is 2 ad, 2 into 4 into f plus BD, that is 6, that is equal to -2. So therefore 8F, that is equal to -2 minus 6, that is -8. So F equal to -1. F is -1, so therefore C into D is 2. So 2C minus 1, that is equal to 1. So 2C equal to 2. So therefore C equal to 1. So C is 1. Then D is 2. So A is also 2. A is also equal to 2. A is 2. B is 3. C is 1. And okay, A, B, C, then D is 2. F is -1. So therefore, the function f of x, we can write that will be equal to 2x square plus 3x plus 1. And g of x, that is equal to d 2x minus 1. Then we have to find the value of f of 2 and g of 2. So therefore, f of 2 plus g of 2. So therefore, f of 2, that is equal to 2x square. So 2 into 2 square plus 3 into 2 plus 1. Then plus g of 2, that is 2 into 2 minus 1. This will be equal to 2, 4, so 8 plus it is a 6 plus 1 plus 4 minus 1. So these two will cancel out. 4 plus 6, 10. This is equal to 18. So 18 is the correct answer. And here it is told f of x, that is equal to c plus 1 into x square plus 1 minus c square into x plus 2k. And f of x plus y, that is equal to f of x plus f of y minus xy for all x comma y belongs to R. Then the value of mod of 2 into f of 1 plus f of 2 plus f of 3 plus dot dot till f of 20. That value will be equal to how much? That we have to find out. So now here suppose if you want to find f of 1, okay. So here if you do limit y tends to 0, f of x plus y minus f of x divided by y, then we will get limit y tends to 0. So f of x plus y is f of x plus f of y. So f of x will cancel. So this will come f of y minus xy by y. So this I can write this as f dash x. This is f dash x. So if we put y tends to 0, y equal to 0, if I put, this will be 0 by 0 form. So from here we can say that this will be limit y tends to 0. This will be f dash y minus d by dy we will do. So this is x by 1. So therefore f dash x, that is, if you put y equal to 0 here, this will be f dash 0 minus 1. Here actually we are applying the L'Hospital's rule. L'Hospital's rule, which says that if I have limit extends to a f of x by g of x, then if it is 0 by 0 form, then we can write it as it is equal to limit extends to 0 f dash x by g dash x. Okay, so then here minus x, this is, so f of x. So if we can write this as dfx by d of x, so then if we integrate this, then we will get minus x square by 2 plus f dash 0 into x plus some constant, that is lambda. And here it should be 0 by 0 form only. So it means that f of 0, that should be equal to 0 only. F of 0 is 0 only. From here also we can see f of 0, that is 0 plus 0. So 2 into f of 0 minus 0. So it means f of 0 is 0 only. So f of 0 is 0. So therefore it should not have any constant. Therefore we can say from here that lambda should be equal to 0 only, since f of 0 is equal to minus 0 square by 2 plus 0 plus lambda. So this should be 0. So lambda also should be 0. So therefore the function f of x can be written as minus x square by 2 plus f dash 0 into x. Now here if we put f of 0, so here if I find f dash x, that will give us 2x into c plus 1 minus plus 1 minus c square, and 2k is a constant, so it will be 0. So if you put f dash 0, will be obviously 1 minus c square. So f dash, so therefore f dash 0 is 1 minus c square. So we can write it as minus x square by 2 plus 1 minus c square into x. Now if we compare these two equations, so now therefore here it is told that f of x, that is equal to c plus 1 into x square plus 1 minus c square into x plus 2k, and that is coming same as minus x square by 2 plus 1 minus c square into x. So therefore from here we can say 2k equal to 0 and c plus 1, that is equal to minus half. So c will be equal to minus 3 by 2. So therefore this function f of x can be written as minus x square by 2 plus 1 minus 9 by 4 into x. So this is minus 5 by 4. So this is minus x square by 2 minus 5 by 4 into x. So therefore now we need to find summation f of x, where x goes from 1 to 20. Actually we need to find summation f of n, where n goes from 1 to 20, and twice of that, then its mod we have to find. That has been out. Since why this we can write it as summation f of n, n goes from 1 to 20 into 2 and mod of that. This value we have to find out. So this will be written as mod of 2 into summation n goes from 1 to 20. So from here we can say f of n, that will come what? Minus n square by 2 minus 5n by 4. So this we can tell this will be minus n square by 2 minus 5n by 4. Then mod of that. So this can be written as mod of minus of summation n goes from 1 to 20 n square. Then this will be minus 5 by 2 summation n 2 to the 4. Okay, n goes from 1 to 20. This we have to find out. So mod of that, so we have to take the positive sign only. So this will be summation n square, n goes from 1 to 20 plus 5 by 2 into summation n, n goes from 1 to 20. So this will be, so summation n square, as you know, it is n into n plus 1 into 2n plus 1 by 6. So this will be 20 into n plus 1. So 21 into 2n plus 1. So 40 plus 1, 41 by 6. Then plus this is 5 by 2 into, this is an AP only. So it is n into n plus 1 by 2. So it is 20 into 21 by 2. This 4 5s are 20. This is 6, 3 2s are 6, 3 7s are 21, 2 10s are 20. So this is 70 into 41 plus 25 into 21. So this is 7 1s are 7, 7 4s are 28, 2870 plus 25 1s are 25, 25 is a 50, 5 25. So this is equal to 5. This is 9. This is 33, 3395. So the answer is 3395. 3395 is the answer. So hope all of you have understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter functions. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. And please install our Sapience education application, where we shall upload some important homework questions based on the previous year JEE Mains exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.